Wildcard masks. So how exactly do you tell an access list entry that you're concerned about identifying a single subnet on a remote network? Have no fear, wildcard masks are here. Let's jump in. So let's say that you and I are driving down the road and we want to get a car wash. So we pull into the car wash and we, at the counter, ask them for the deluxe car wash. And they ask us very specifically, what type of air freshener would you like? We say, one that freshens the air? And she goes, no, what I mean is, what scent of air freshener would you like? Now, if we really don't care about what type of air freshener, we could just say, we don't care. And you know what, my friends? That is the job of a wildcard mask on a computer network today. A wildcard mask's responsibility is to identify some components, some portion of an IP address that we just don't care about. So that first bullet of what they do has already been identified. In this MicroNugget, we're going to take a look more specifically at how they do their magic and then where they can be used as well. One really great way to understand how a technology works is to see a practical application of it. So let's say we have a goal that was given to us by a manager that says, I want you to deny any traffic if it's sourced from the network 172.16.56.0. That's this network right here. And we want you to filter that, let's say, inbound on R2's interface right there. So we're going to have to create an access control list to do that. But how in the world do we write it? Because this network 172.16.56.0, any hosts on that subnet, and let's assume that it's a 24-bit network, any host is going to have a value of something in that last octet. It can be 1 or 2 or 3, all the way up to 254. So in our access control list, how do we tell the router that we care about matching on the first 3 octets, but we don't care about matching on the very last octet? My friends, that is the exact application of how a wildcard mask works. A wildcard mask simply takes this last octet, which I have right here, and the wildcard bits say, I don't care. What do you mean, Keith? I don't care. Well, if there's a bit on in the wildcard mask, it means this bit above it could be anything. Doesn't matter. We're not going to compare. It's a wildcard. It could be anything, and it'll still be considered a match as long as the rest of the network address matches. So here's a wildcard mask. Here's a wildcard mask. So the last 8 bits of the wildcard mask indicate that the last 8 bits of the address being matched on in the ACL doesn't matter one bit. Now, what does matter are these first 24 bits. So what do we do there? Well, the wildcard mask only doesn't care if the bits are on. So in the wildcard mask, if the bits are off, we'd have 24 bits all the way down to the end. And that indicates that these first 24 bits, they do have to match inside the ACL. And the last 8 bits, because the wildcard mask bits are on, we don't care and they don't have to match. So after all said and done, that is the exact method that's used by the wildcard mask to indicate, I don't care what air freshener you give me, or in this case, I don't care what the value of the last octet is, because the wildcard bits are all on in that last octet. I'm not even going to check it. So when we put in an IP access list inside of a router config, it's done in dotted decimal, but behind the scenes, it's doing the comparison. In the wildcard mask, if there's a 0, the corresponding bit that we put in for the matching has to match. If the corresponding bit is a 1, it's a wildcard, and the access list isn't even going to check those values. It doesn't even matter what they are. Let me show you with a practical application of this. We'll bring over R2. So this represents this R2 on our network, and let's go ahead and put in this exact access list. Now, a couple of things. We want to make sure that we know of all the existing ACLs first before we just start adding one. So I'm going to take a look to make sure we don't have any ACLs. And then from configuration mode, we'll create an access list that's going to deny the 172.16.56 network and pay special attention to that wildcard mask. The wildcard mask right there, the 000.255, is what's telling that ACL that the last octet, the all ones, doesn't have to match. It could be anything. So I also want to apply this to the correct interface. So show CDP neighbors shows me that my gig 30 interface is the one that's connected right here over to R4, and we'll apply the access list we created inbound on that interface, and then just verify that it really did get applied. So my friends, that's the magic of a wildcard mask. Anywhere there's a bit on, it just simply doesn't care. So in this MicroNugget, the concept, the topic was wildcard masks. What do they do for a living? Pretty simple, Keith. They say what they don't care about. How's that? I don't want this air freshener. I don't care about the air freshener. I don't care about the last octet. It's all the same. That's what a wildcard mask is doing. Where there's a bit on, we don't care about matching. How they do it is they do a one-to-one comparison. Bit for bit for bit for bit. If the wildcard bit is on, it's like a party. We don't care what the corresponding bit is. It could be anything. If the wildcard bit is set to 0, it's not wild. That bit has to match. And where can they be used? They can be used in access lists and one other place. Besides an access list, they can also be used in a network statement. So if you want to, for example, on R1, you want to say, I want to include in a routing protocol all the networks, all the interfaces that begin with 10, you could use a wildcard mask of 0.255.255.255. And what that would say is that, okay, the first octet has to be 10, and that has to match, but the last 3 octets can be anything, and that's one other application where you can use a wildcard mask. I hope this has been informative for you, and I'd like to thank you for viewing.